Hi everyone, and welcome to Lesson 5, More Linear Systems. At this point in the unit, you should have learned how to use elimination or substitution to solve systems. Now, again, we've talked about this before, but this word solve is very important. There are three answers to the word solve when you solve a system, three options. It's either intersecting, and in which case you would state the POI, or it's overlapping, in which case you would state three examples, or there's no solution. So when I say solve, I'm asking you to understand and tell me, using elimination or substitution, which of these three cases we're in. There are only three examples in this lesson, but basically what you'll notice is that there's an extra step to these problems. And so what you need to be able to do is recognize the extra step needed to solve these systems. So for example, if we look at example 1, I can see that this looks very similar to a system we've done because it has the brace, it has two equations, but they're not really in the form of y equals mx plus b. We recognize that there are fractions, okay? Now the key to fractions is that we want to get rid of them, okay? So most guys, when they see this question, they think of, well, I can just find a common denominator. And we actually don't want to do that, okay? What we want is actually no denominator at all. Now, before we get started, I just want us to remember that something like this, like x plus y over 3, if I were to write that in a straight line, if I wrote it as x plus y divided by 3, that's actually wrong because the x is by itself and only the y is divided by 3. So there are actually brackets needed to join the x and the y together as a binomial. And that's true of the fraction as well. Okay, so before we do anything, I just want us to recognize that there are these things that I call implied brackets on all of these numerators. Now the next thing we need to do is recognize that the way we get rid of fractions is by figuring out the LCD of each of these equations, equation 1 and equation 2. So if I look at the denominators 3, 7, and 1, I should be able to tell that the LCD is 21. I have 3, 1, 1, 1. The LCD is 3. Now here's the key. The step is to multiply each term by the LCD. Okay, so for example, what I'm going to do in equation 1 is I'm going to rewrite the line like this. And then I'm going to multiply every term by its LCD. So by the way, there are 1, 2, 3 terms in this line. 21, 21, 21. So I'm multiplying. Now, there's a common mistake that gets made here. What guys want to do is they want to distribute, but we're not going to do that because the whole key here is, remember, we want to clear fractions. And the way we clear fractions is by reducing the 21 and the 3. I know 21 divided by 3, that's 7. 21 divided by 7, that's 3. And I can't do anything here because there's a denominator of 1. So if things aren't working out at this stage, what that probably means is that you've picked a bad LCD. So maybe go back and check that. Now what we're going to do in the next step is just kind of a tidy up line. So you'll notice that in this line we have no denominators. We have successfully cleared all fractions, which is what we want. And now I have something that looks closer to a linear system. So I will distribute. I will simplify by distribution. Now don't forget, okay, that we have to distribute the negative and the negative here. And then I will collect like terms, which is negative 2x plus 10y equals 42. And I'm even going to go and do the extra step of dividing everything by negative 2 just to make it look a bit nicer. Okay, so this becomes x minus 5y equals negative 21. Okay, so that's equation 1. That's a lot of work just for one thing, one line, but we got to do it. Okay, so let's look at equation 2. I have 2y minus x over 3 plus x equals y plus 1. And my LCD in this case is 3. So I'm going to go and multiply each of these terms by 3, all of them. Okay, knowing that there's 1, 2, 3, 4 terms. Okay. There's only one fraction I can clear here. It's the 3. And now I'm going to copy, or I'm going to clean up the line in this way. 3y plus 3. I'm going to collect all x's and y's on one side, so I'm going to get negative x plus 3x plus 2y minus 3y equals 3. 2x minus y equals 3. All right, so now basically what I have to do after all that work, I call it an extra step, but it's a big extra step, is essentially I'm going to rewrite this system in this simplified way. So I've simplified equation 1 to x minus 5y equals negative 21, and I've simplified equation 2 to 2x minus y equals 3. At this stage, you can use elimination or substitution. I actually think substitution might be nicer here because, well, I can see that I can isolate x in 1 quite easily. X is 5y minus 21. And then I'm going to sub 1 into 2 to get 2x minus y equals 3. So 10y minus 42 minus y equals 3. That gives me 9y is 3 plus 42 is 45, and y is 5. Okay, that's half the answer because, of course, to find, we can do it here, to find x, I'm just going to sub into x equals 5y minus 21. That's going to be 25 minus 21. X is 4. Okay, so we have solved the system. We found the POI. This is an intersecting system. So my solution statement should be the POI is 4, 5. Excellent. Of course, I could do the extra step of going back into the original thing and checking it, but we're not going to do that here. Okay. What I'm going to do, what I suggest you do, is pause the video now, try this one, and then come back and view the video to see if you got the right answer. All right, let's take a look at the last one. So as we said, one of the things we have to do is recognize that there's sometimes an extra step in the question. And in this case, the biggest thing we should recognize here is that we, instead of having x and y only, we have x, y, and z. And by the way, what this actually is this is a two-dimensional coordinate. You don't really need to know this, but it's nice to know, where we have x and y on a 2D plane. When we have x and y and z, we actually have a third plane. We call this one x, y, and z goes up. Now, you don't have to visualize this at all, but what you do need to know is that when you state a coordinate, it still goes in alphabetical order. Okay? So the x still goes first, the y still goes second, but now you're slapping on the z at the end. Okay, so if we were in class one-on-one right now, and I asked you whether or not we would use, substitution or elimination, I'm sure that most people in the class would recognize by the first equation that this is quite nicely teed up for substitution because z is already isolated. Now, what we're going to do, remember, we can never substitute an equation back into itself. So what we're going to do is sub 1 into 2. And we're going to see why in a second. So what I'm going to do is write 7x plus 6y plus, and instead of z, I'm going to write the equation for z. Okay, so this is actually nothing new. It's just kind of longer. Okay, so I'm putting that in for z and equals 1, of course. Now, this will simplify to 8x plus 9y equals, and I'm just going to bring the 14 to the other side, negative 13. Well, normally at this stage, we would only have one variable, but you'll notice that we went from x, y, z to x and y only. Now, if I had another equation, I would be able to solve this. Let's call this equation 4. If I had a fifth equation with just x and y, I would be able to solve this system. So if I look, well, I can't sub 1 back into itself. I've already subbed 1 into 2. So my next most obvious step should be to sub 1 into 3. Let's see what happens when we do that. So I got 4x minus 2y minus 5, and then z is x plus 3y plus 14 equals 11. So we get 4x minus 2y minus 5x minus 15y minus 70, I think. 70? 70. Okay, equals 11, which becomes negative x minus 17y. Y equals 81. And let's write that as x plus 17y equals negative 81. So what we'll see is that once again, we went from x, y, z to an xy equation. I'm going to call this number 5, and hopefully it's becoming clear that what I can do is solve this system, this xy system, just for x and y. Let's forget about the z for now. So what I'm going to do, just to change it up a bit, I am going to use elimination, and I'm going to multiply the second line. I'm going to copy and paste this first one. I'm going to multiply the second line by negative 8, and the reason I do this is so that I don't have to worry about signs when I actually combine the two things together, the two lines together. 6, 48. All right, so we're going to get negative 127y equals 635. And believe it or not, y ends up being a nice number. Y equals negative 5. Oh boy. All right. So now we're going to sub y equals negative 5. We have to sub it in either 4 or 5. We can't sub it into 1, 2, or 3 yet because those also contain z values. So we're actually just finding x at the moment. Okay, so maybe let's do it here. X plus 17 times negative 5 equals negative 81. So x minus 85 equals negative 81, so x equals 4. Okay, now what I can do to find z, I'm going to sub x equals 4 and y equals 5 into 1 or 2 or 3. But I think it's pretty obvious that 1 is the easiest one because that was the one that was isolated already. So this is x plus 3y plus 14. So z equals 4 plus 3 times negative 5 plus 14. That is 4. That was weird. Negative 5 minus 15 plus 14. Z equals 3. So we are not going to write it exactly the same way as we wrote the POI because we don't really actually know what this answer is because it's in 3D. So what we're going to do is say the solution to this system is, and we have to put it in order of x, y, and z like this in the following way. Now I will take 1 second here to show you, okay, that this works. Okay, so what's the best way to do this? I'm gonna cut this and copy. All right, so let's check to see if this works. Okay, so I'm going to sub in x, y, and z values here just really quickly. So 3 equals 4 minus 15 plus 14. Does that work? This is 4 minus 15. That works. Okay, so the next one is 7 times 4 plus 6 times negative 5 plus 3. Well, that's 28 minus 30 plus 3, which is negative 2 plus 3, which is 1. Yep, that one works too. And then we've got 4x minus 2 times negative 5 minus 5, 3 equals 16 plus 10 minus 15 equals 11. All right, so we've now convinced ourselves that that's the answer. So when you get to these ones with x, y, and z, the key is to find a nice substitution and then just follow the steps through as you already know them. Okay, give the homework a try, guys, and if you have any questions, feel free to see any of the grade 10 teachers. Good luck.